Hello and welcome back to your daily dose of code. So, last time we went ahead and we added a few tile types by defining a few classes. So we have the tile type class, which has all of the different things that a tile can have in it. So we have the name, the background color, the foreground color, and the render string. And we set up constructors so that we could go ahead and cleanly create a few tile types. So we have air, grass, and wood for now. Air is just empty and blue. Grass is green and dark green and is some hashtags. And then wood is just the lines. Pretty good. I'm actually going to add one more because I thought it would be cool. I had an idea for something we could do in the future. So I'm just going to add public, static, read only. Just going over once again from last time. Public means anything can access it. Static means that there's only one of them in existence. Read only means that it's only being set once. Then we have tile type. I like how it suggests gold. It can tell I'm making a game, the machine learning part. There is a machine learning in Visual Studio now, so it'll try to suggest things to you. Sometimes it does a good job, sometimes it does a poor job. You can go ahead and actually hit tab for it to take its suggestions. For example, if I go ahead and hit tab right now, it'll fill that entire first part out for me because it was correct. It's not correct now though. Putting tile type here wouldn't work because we're actually supposed to be putting the string that is the name. And I'm just gonna go ahead and do water, console, color dot, what is this, the background? Background. So we'll do dark blue, and then we will do console color dot dark cyan, and then we're going to do a tilde. Ooh, look at that. That looks very wavy. That looks like water. I've got a pretty cool idea for this that's going to pay off in the future. Probably not for forever at the rate we're going, though. That's okay. Taking our time is fine. This is about learning, right? This is 100% about learning. So, now that we have our 4 types, how exciting. Air doesn't actually make much sense anymore now that I think about it, because I've kind of decided I want to do top-down at this point. It's not too late for me to make decisions like that. But let's go back to our main class, because right now all we're doing is we're going through the size of the map and we're drawing grass, right? And then we're just drawing a big square of grass. So if I actually go ahead, go to my main screen here and hit play, you'll see that we have exactly that. We have a big block of grass. Looks good. When I expand this, for some reason the color leaks out here. I've got an idea on how to solve that. I'm going to try writing a single empty character. It's an idea. So let's see if this works. If I go ahead and just add one empty character, I think. Oh, no. I have to set the background color to black, then write an empty character. I believe it just takes the color of the last character and continues it. Yes. No! Are you serious? No, it's angry again. Why is it angry again? Because when I do this, it should... You see, this is odd. Not actually sure why. I'm actually gonna make it write egg. Welcome to me debugging. Alright, we're gonna debug this. We're gonna figure this out together. So I'm gonna write egg because I wanna see where this is being put in and if it's actually setting the console color to black. So there we go. So there's egg. Now when I do this, it's actually fine. So I'm going to assume that there's some sort of optimization going on here behind the scenes that I'm not controlling, which is treating the empty character like a legitimate empty character. That's fine, but we don't want that. So we're going to have to end it with something other than... shoot. Here's what we'll do. You won't be able to see it. Genius moment here. We'll make the console foreground. I don't want like a bunch of dots or something on the side because that would look bad. But if the background color and the foreground color are black, then we can write whatever the heck we want. I'll just put a dot. And boom! You can't see the dot because the foreground and background color are the same, and if we expand this, hopefully, there we go. We have our square. It's not screwing up on the side there. Brilliant. Very nice. And it hides that text at the end too, which I guess is okay. Not really intended. Alright, so we have a bunch of grass. Brilliant. That's exactly what we expected to get. Let's go ahead and add some code comments. This is something I probably should have said a while ago. All you do is you do 2 slashes, and then anything after those 2 slashes will not be included. It's just for you. I'm just gonna write this prevents green from leaking to the right. Just for myself, so I remember why the heck I did this. Adds shifts to next line. We'll go ahead and actually comment all of this. Writes a full row. Writes the entire grid. I guess it's really more of drawing than writing at this point. Anyways, it doesn't really matter. Just putting a few comments in so that we can remember what we're doing. Now, what we're doing here is we're kind of manually doing this. We don't really want to manually do this. We can come up with a way better way to do this, and that is by giving the tile itself the power to do this. How do we do that? Well, let's go ahead and look at that. So we zoom in a little bit. Instead of these 3 lines, I want to just be able to do tiletypes.grass.render, right? That would be really convenient, because then we can just call that on any tile type. So, oh, I said I'd do one at a time so I don't confuse you guys. Back here in tile type, let's go ahead and do that. We can actually add our very own method here called public void, because we don't need to return anything. It's just going to render. Public void render. We're not going to send any parameters in inside of these parentheses, so we can just leave it just parentheses, nothing in there. And then over here, let's go ahead and actually do the rendering. We can literally just take this, take it, put it in here, and then all we have to do is, instead of doing tiletypes.grass, this may not be a tiletype.grass. This is just a generic tile type. We can get rid of this, into this, into this. What we have done is we've made this generic. Console.background color equals back color, which is this, which was set here. So if I have tiletype.air, and I do tiletype.air.render, it's going to set console.background color equals to cyan, foreground color equals to black, and then it's going to write the render string, which is nothing. So now, over here in program, I could just do tiletypes.grass.render. It doesn't need anything. Boom. This is much cleaner, and it also makes it so that we can do this with any of the tile types thing, which we're going to talk about in a second. It's about to get saucy. It's about to get saucy. We're going to start mixing and matching types. All right, so let's go ahead and hit play. See, it still works. Still works. And we've made it a whole lot cleaner. We're actually going to go ahead and do another one, because cleaning your code is very important. We'll go ahead and do public void. Actually, we're going to do public static void, because we're inside of a static class and there's only going to be one instance of this. Public static void, and then we're going to call it setup line, because all of this right here is being called in the loop, and that's kind of ugly. So instead, I'm going to take all this, move it into here, and just call setup line here. You can do this with all of your code. You can clean it up and break things down into simpler, smaller pieces. Now, if we ever want to change how the line is set up, we just edit this method. It's called here. It's the same as just having all this written out here. But now we can go ahead and break it up a little bit. Make it a little bit easier to understand. So now it's a lot easier to understand, because now for the full row, we just render each one of the tiles, and then we go ahead and we set up a line afterwards. Render the whole row, set up line. Render the whole row, set up line. Beautiful. This may be a little bit better if we call it set up next line. What I did there is I right-clicked on the symbol and I clicked to rename, which will change it everywhere in all of my files. You can also just manually rename things. I feel like saying set up next line is good because we only do it after we've already set up a line. It's getting it ready for the next one. All right, so let's go ahead and make the actual grid. Right now, we're kind of cheating. We're getting tile types.grass and we're rendering it for this whole row. But what if we don't want it to be tile types.grass? What if we want to actually store in memory a bunch of tile types and render them out? Because right now we're just kind of drawing the same thing over and over again, and it's not actually being stored anywhere. This is just kind of a test environment we have set up for this. Let's do the real thing. So let's design it. You know, that's what the cool kids do. They design things. So we have a grid. We've already talked about this, but we'll go over it again because this is going to be really important, because this is like the entire foundation of our game. We have a grid. It's 32 by 32. We have Y and we have X. All right. Which means we're going to have all of our materials and stuff. And let's say this black is one material and this purple is another material. How can we store different materials inside of one piece of data so that we can go ahead and render multiple types? Now you may be thinking of an array, because we've used an array before. And an array would actually be good for storing multiple of one thing, right? Because we can go ahead and do public, or not public, we're inside of a method. We can go ahead and do tile array, tiles equals new, I can spell, tile, size X, size Y. See how it suggested that? That's pretty neat. I still am very impressed by how good this is getting. However, it has suggested a multi-dimensional array, which we're not going to use because I don't find multi-dimensional arrays necessary. They're slower and they only make things slightly simpler. You can actually do this. Tile, comma, inside of here, tiles equals new tile, size X, size Y. And then you can actually do tiles, say if I wanted something at the position 0, 5, I can do that. You may be wondering why I'm showing you that I can do this if I'm saying that we're not going to do it, and it's because I want you to know the option is there. If it's that much easier for you, you can actually go ahead and use multi-dimensional arrays. But I will tell you, there is a cost. Does it matter to you in a game like this? No, but it's so much little effort to do it properly that doing it improperly doesn't make sense in this case. Because instead, if you know a little bit of basic math, we can just do everything ourselves. Watch this. All right, so on the iPad again. A multi-dimensional array is really just an array that smartly changes the access based on where you're asking for it to go. So it is still actually just one really long line. It's just splitting it into smaller lines where it knows, well, this is the y equals 0, this is the y equals 1, this is the y equals 2, and it goes ahead and it does the logic in order to determine where to go on its own. It's really simple math. We're going to do it ourselves in a second. There's also jagged arrays. Jagged arrays are kind of neat. It's an array of arrays. This is different than a multi-dimensional array because a jagged array is actually multi-dimensional, and we'd have to do it like this. So while a multi-dimensional array, as we just talked about, oh shoot, is it like... Oh god, that's so weird. So it's an array of 32 long arrays. And actually there's nothing that prevents the arrays within those arrays from being a different length. But that's why it's called a jagged array. Let me show you on the iPad. So if we go ahead, and we're not going to use a jagged array, but I think explaining it is still important. So if we do tile array tiles equals new tile, and we'll just write out the 32 because it is 32, and then like that. So let's break this down, right? Okay, so let's look at this part of it. This will make it a little bit simpler. This here is the first thing that is read. So we have an array. Notice how it's not defined the length of this one here. But we have an array of 32 long tile arrays. So what this looks like in memory is we have the array. And they don't have to be the same length, which is why it's called a jagged array. See, it kind of looks jagged because they're all jutting out at different lengths. And then each of these are an array. So these each have their own stuff inside of them. They don't have to be the same length. Anyways, what we're going to do is we're just going to use a normal array, like a normal person. We're going to go ahead and we're going to do an array of tiles. And I want this to be accessible everywhere, not just in main. So we're going to go ahead and we're going to do public static, because there's only one copy of this array. Public static tile array tiles equals new tile size X times size Y. This shouldn't surprise you if you know, math. I'll still explain it. If we have 32 on the X axis, 32 on the X times 32 on the Y equals our total tiles. Why? Because that's how you get area. Like, for example, if we have a square that's 2 by 2, the area is going to be 4, because, I don't think I have to explain this, but A equals X squared if we're talking about a square, right? It's pretty simple, just square it to get the area. So if we want to know how many tiles we're gonna need, it's size X times size Y. Very simple. Now, how do we get to a specific tile? Well, how about we go ahead and add some very helpful methods. Actually, how about we go ahead and we abstract this all out? Because I don't want my main program to be completely filled up with all of the logic for handling tiles. So I'm gonna create a new class. I'm gonna right click here. Actually, I can show you this. I'm gonna right click here. I'm gonna do new or add new item. I'm gonna call it, we can call it a lot of things. I think for a game, the most fun thing to call it would be world, because this is going to represent the world. So we can go ahead and do world.cs, and we can go ahead and add it. Boom, we have a new class. Let's go ahead and move some stuff over. Let's take our size X, size Y, and our tiles, and we're gonna take them all out. That's right. We're gonna move them all over here into world. It's fine. Don't worry about it. Everything's gonna be fine. Now that it's in world, we're gonna notice in program it's crying because we don't have size Y or size X anymore. Well, if you remember, it's public and it's constant, which is really a fancy kind of static that never changes. So we can just do world.sizeY, world.sizeX, and everyone's happy. All right, so let's go into the world. Let's go ahead and make it useful. Let's go ahead and make the world actually usable. So we want to be able to access any tile here given an X and a Y coordinate. Public tile. We're returning a tile this time. We're actually having a return type. Remember, the second thing you write is going to be the return type. Public, anything can access it. Tile, we're returning a tile. And we're just gonna call it get tile. Parameters. Do we need parameters for this? Think about it. Yes, we do. Because we need to know the X coordinate and the Y coordinate that we want to get the tile at. There we go. We have a happy method. You may be looking at this and asking, wait a second, why is it red squiggly? Because we're returning a tile, or we've said we're going to return a tile, and we haven't yet. But we're going to. Don't worry. So let's go ahead and talk about this. Int. Int means a number that doesn't have a decimal. That's all you need to know. We're expecting an X and a Y, which are just numbers without a decimal, just normal integers. So how are we going to get it? We're going to return, which means we're finally going to, you know, make this happy because we're returning something now. Return tiles X plus 32 times Y. Now you may be asking, why? Well, I mean, that's a good question, but it's really just math. All right, so if we wanted to get something at the position, geez, I hate explaining math, but if we want to get something at the position, for example, let's say we have a grid, right? Make it real simple. We'll make this grid 4 by 4. And I want to get something at 2, 2. So X equals 2, Y equals 2. That is awful, but who cares? Let me show you what the problem is. We forgot to start counting at 0, because this is actually 0, 1, 2, and this is actually 0, 1, 2, 3, and this is 0, 1, 2, 3, because arrays start at 0, our logic starts at 0. So actually 2, 2 is going to be here, and that means that the math is going to be 2 plus 2 times 4, which is going to be 10. Let's count and see if it's correct. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See? The math works out at the end of the day. If we want to get the position, we just do the dimensions, and then we take the first dimension, and then we shift the other dimension by the total size of the dimension, right? And we can actually simplify this by doing size y times y. Assuming that the actual thing is always a grid, I guess we can actually simplify this a little bit further. We don't need a size x and a size y. We can just do size, because they're going to be the same always. We're not making a rectangle, we're just making a square. Makes it a little bit simpler. Boom. Brilliant. So, yes, now this is just going to be size times size. Very nice. Okay, so now we have the logic to get a tile. I've proven it mathematically. I even drew a diagram. Trust me. Now we're going to go ahead and do the same thing, but set tile, because maybe we need to set it. Public tile, set tile, int x, int y, tile, because we need an actual tile to be passed into set. And all we have to do, it knows, hit tab. You may not have it suggested for you, but once again, we're going to the tiles at this position equals the tile that we've sent in. This shouldn't actually be tile. I made a mistake. This should be void. We're not returning anything. Brilliant. So now we have get tile. We can get the tile at that position. Set tile. We can set the tile at the position. The world is now pretty damn usable. Now, a few things that we should keep in mind. When we do this, public static tile tiles equals new tile size times size, I want you to know that there's a little bit of a wacky thing that's going to happen here. When you create an array like this, that holds classes. Classes are what are called reference types, which means they can be null. What that means is that they don't necessarily exist. When we create this, we're creating a container for tiles. That doesn't mean there's actually tiles in them, and that means if we try to get a tile at XY and then get its color, if there's not a tile actually there, we're going to get what's called a null reference exception. It's going to get very mad at us because there's literally nothing there. We can solve this by just making sure that we fill the container. So inside of the constructor, you guys know what a constructor is, we've done it before. Constructor runs when the class is created. So when the world is created, this will run. Public world, we don't actually need anything to pipe into the world. Alright, or I guess pipe has a different connotation in programming, to pass into the world. We'll go ahead and initialize this. So we have to put a tile into every slot inside of the array so that they're not null. We've used a for loop before, this shouldn't be scary. For int I equals 0, we're going to start at 0. Well, I is less than the length of the amount of tiles in the world. We're going to keep incrementing each time. So basically this is going to run from 0 to 32 times 32 because tiles.length is going to be 32 times 32. All we have to do is tiles I equals new tile. Now, this is still incorrect. You may be wondering how I can see these things ahead of time, and it becomes intuitive at a point. You start thinking ahead to everything you've done. Tile itself has a little bit of a issue, which is that it's completely empty. We haven't actually done anything with it. We've defined tile types, which is like how they render and the types, but we haven't actually defined tile. So let's go ahead and give tile two things to begin. We'll give it a public int, or it's going to be lowercase because it's just a field. Public int health, and we will do public tile type. So it's got a type of tile it is, and then it's got a health value, both of which are useful. Why would I have to declare it as nullable to class? Interesting, I don't know why that's complaining. A little bit concerned. We're just going to not worry about the warning it's giving me there for the second being. But we want when we create the tile, so our constructor, we want to take in the health value and the type. Actually, we can simplify this a little bit. All right, let's make things a little bit simpler. I think we're getting the hang of things a little bit. Let's not define the health here because the starting health is probably going to depend on the tile type, actually. So let's go ahead and add another thing to tile type. Public int max health. get set happy property. And then we're gonna need to correspondingly make it so that we set that when we create it. At max health. This dot max health equals max health. These are all gonna complain now because they're expecting one extra thing to be passed in. The health of air will be 100, I guess. I don't know how we're destroying air. We'll make the health of grass like 20. The health, it doesn't really matter what these numbers are. I'm gonna be honest. I don't even know if we're going to use the health at some point. I'm just trying to make this a little bit more in depth. All right. So now we've added a maximum health type to each tile type. So when the tile is created, given the tile type, we'll do health equals type.max health. So we immediately set the tile's health to the maximum health the type can have. And then type, or this dot type equals type. Very nice. This is cool because now each tile has a tile type and has a health. And when we go all the way back to our world here, it's going to complain and say, excuse me, you didn't give me a type for this. Don't worry. I'm not updating my iPad right now. We can go ahead and do tile types dot grass. For the world, for every single tile, we're going to set the tile to a new tile that is tile types dot grass. Very nice. Very nice indeed. All right. So now if we go back to our program class, let's actually go ahead and make sure that the program has a world. Public static world. Here's our world. Why are we getting these complaints all of a sudden? I shouldn't have to declare a class as nullable? This is kind of odd. Classes are always nullable. Oh, okay. Is that why it's complaining? That may actually be why it's complaining. No? I'm actually really confused as to why it's making that complaint. Classes are always nullable. I never... This is a, Oh, shoot! No, this should be a public... This should not be static. Alright. This should not be static because each world has its own copy of tiles now. Is it happy now? Is this just a new complaint if you're not... Hi, this is post-production Spike. I know the screen is blank, just ignore that. I'm gonna change the way I fix this problem and just cut the original fix because it wasn't very good. That means that the next thing you see is correct, but then there's gonna be a little bit of a discrepancy after that. Just keep in mind that... Just keep the next thing, okay? Thanks. Hey, this is me after the fact. This part I did didn't sit well with me because everything about it's kind of wrong, alright? I don't really see a reason to use a property here, I kind of just forced it, and having this inside of the program, the constructor just made me feel bad. We're gonna get rid of this, we're gonna make this back into a, just a field, and we're just going to set it in the single line, like this. I think that this is just better, okay? And this may seem like something really tiny to get held up about, but I think that this is better to teach you because, yeah. All right, this is a lot cleaner. Thank you. Yeah, I'm editing the video and I decided that I didn't like how I did it. I like this more now. Thanks. Now when we draw, we're going to do world dot get tile x, y dot tile type or dot type dot render. So now we're actually going into the world, getting the tile at xy, which does this, which is going to return the tile. We know that the tile has a tile type, and we know that the tile type has a render function. That's pretty cool, because now when we do this, it should work, and we should get grass. And we do. It still works. Now you're asking yourself, why did we do this? This seems a whole lot more complicated. We've got no extra functionality. But that's where you're wrong. Now that we have this world class and we have a tile array tiles, let's go ahead and add some logic to this creation. Let's do if I modulo 2 equals 0, tiles I equals new tile types I dot grass, else tiles I equals new tile types dot water. Modulo is a pretty cool operator. This one right here, it's a percent sign. Modulo means the remainder. So if you've ever done, you know, once again, pretty basic math, but I'll explain it anyways. If we do 3 divided by 2, you know, you can take 2 out of there, but you're still gonna have 1 over 2 remaining. In case you didn't read that, I just threw on the screen. This is kind of absolutely not how a remainder works. I don't know what I was actually doing here, but I do correct myself like a few seconds later, so just give me 1 second. 3 divided by 2, so it'll do the math. It'll go 3 minus 2 equals 1 minus 2. Wait, we can't do that. We don't have enough, you know, left over. That's not how division works. So the 1 is the remainder, and that means, you know, we have a remainder. If we do I modulo 2, that means it will be 0 if it's even, because there won't be a remainder if it's even, and there will be a remainder of 1 if it's odd. I could reverse this and do not equals to 0 to get all the odds, or I could do all the evens. See? Very clean, very neat, very nice. It's just a way to get every other one. So any even I is going to run this, any odd I is going to run this. Now you're gonna realize we are setting it to grass, water, grass, water, grass, water. So the result of this should be pretty predictable. And if we hit play, look at that. We got exactly what we had expected. We have lines of grass and water. That's pretty cool. Hey, we could make it even more complicated. Watch this. We can do... Oh, shoot. Okay, this is actually going to get a little bit more complicated. We're not going to use this for loop anymore, actually. We're going to build a new one. We're going to do for int x equals 0. This is going to be the exact same as the loop in the other script. We're going to go through all of the x positions, and we're going to go through all of the y positions, and we're going to do tiles, or actually, I could just use set tile here, actually. We can do set tile xy new tile cool. That's actually a lot cleaner. We can just use the set tile class we've already made, or not class, method. We can use this rather than doing this inside of it. All right. So we're going through all the x and we're going through all the y, and we're setting all of the tiles at the xy coordinate to water. Let's make an island. just a little bit of math required here. All we have to do is basically check if the radius is greater than a certain amount. So all we have to do is we'll do this in a really quick and dirty way. We'll do the center c equals size divided by 2, so that's the center point. And then we'll do arc just make it square rather than circular. That'd be a little bit easier. Oh, whatever. We'll do it. D for the distance equals. This is really dumb. Why am I doing this? Equals x minus c times x minus c plus. I'm literally just doing distance formula here. I would explain it, but I feel like you guys are here to learn how to code, not how to do math. Y minus c times y minus c. I'm not even going to bother square rooting it because I can just do a little bit of a test here. If d is less than what would it be a good thing to do here? So if it's 32 across, then we're looking for a distance of like half. I'll just do if d is less than 16 times 16. If d is less than 256, set tile x y new tile types dot grass, else set it to water. Okay, you may be looking at this and going, Spike, you have completely lost me. Let me explain. Because this is mostly math. This isn't like programming concepts right here. This is a lot of math. So let's go ahead and look at our grid. We've got our grid. It's 32 by 32. So the first thing we're doing is we're saying c is equal to size divided by 2. Size divided by 2 is 16, which is smack dab in the middle. 16, or I put 32 like in the worst possible spot. Okay. Anyways, this is going to be 16 by 16 is going to be the middle. All right. Then we're doing distance formula, which if you know distance formula, it's a minus. Okay, wait. It's x2 minus x1. Why did I put that 1 there? x2 minus x1 squared plus y2 minus y1 squared, and the square root of that. Square rooting is really slow in computers, so we're ignoring the square root. Actually, let me explain. So if we want it to a circle that goes out like this far, right? Then we'd say, well, the distance here is about 8. Oh, shoot. I knew that number was too big. This should be 64, actually. Okay, so that distance is about 8, right? So let's go ahead and we want this to be less than 8. We want the distance to be less than 8. Well, we can get rid of the square root pretty easily. All we have to do is square. That's not how you square. The square goes to the right. All we have to do is square both sides, right? And then if we square both sides, we kill the square root on this side. So it just becomes this is less than 8 squared, which is 64. The center point is going to be the same because it's the same on both sides. So this really just becomes x2 minus c squared plus y2 minus c squared is less than 64. What's an easy way to square? Just do the same thing twice and multiply by each other, because once again, it's, you know, we're kind of doing it dirty and fast here. Anyways, now that the math makes sense, let's see if it actually works. Hey, it works! Oh my god, when you look at the... Wow. Now that is some quick and dirty math for you there. But we can actually see that we have created an island. We have actually made an island, and this is where knowing some math comes in handy, like being able to write the distance formula out by hand. There's some things that we can even optimize, like we don't have to define C every single part of the loop. We can actually define C way up here, so it doesn't happen 8 billion times. It's gonna come out with the same result, but we created an island. I mean, that's actually a visible progress we've made today, so that's pretty cool. I'm a big fan of that, so good work, guys. We did it. We did it. We made an island. Oh boy. Alright, see you all next time.